So we had two properties or proofs results left to discuss. So adai ipo paakalam. What were they? What was the next one? It was this: A set difference B intersection B is equal to a null set. Okay, so that is, this is 5. A set difference B intersection B is null set. Okay, so left hand side eduthupo. Left hand side, we need a Venn diagram. Okay, so have A, have B, A, B. A difference B another already theriyum namakku. A difference B is other than B, everything that's in A, this one. Okay, so this is A difference B. What is B? B is this circle, right? This circle. So this circle, and you have this area. Is there something intersecting? Is there an intersecting area? Illa. There's absolutely no intersecting area, and it's kind of easy to think about it. If we consider intersection as plus and this is difference, because we are already subtracting B from A, right? That is what this A set difference B means. You are already subtracting B from A, so it's already gone. B is already out of A. அதுக்கப்புறமா திருப்பி B ல ஏதாவது intersect ஆகுதா அந்த செட் கூடன்னு பார்க்கிறது is so dumb. I mean, it will give you a null set because there is no intersecting area at all. There is no B in this at all. Okay, so this will be a null set. Okay, and I mean, you don't have to represent the RHS as a null set. So this is the proof is just this. Okay, hope you understood that. So let's go to the next one. What is the next one? Next one is this. Okay, so it means A set difference B union B set difference A is equal to A union B set difference A intersection B. Okay, you have, I think you've seen this already, right? So what is this? This is a symmetric difference, right? Symmetric difference. Yeah, you have it here. This is a symmetric difference, right? This is similar to this. Instead of B, you have C here. That's the only difference. Okay, so symmetric difference. Okay, so now let's try to prove this. Another A, sixth one. A set difference B union B set difference A is equal to what? Is equal to is equal to A union B set difference A intersection B. A union B set difference A intersection B. Okay, fine. So now let's take the left hand side of the equation. We draw a Venn diagram. You have A, you have B, and you've already seen all this. A set difference B is this. Okay, B set difference A and the union of these two is obviously the entire shaded region. It's already passed on. Okay, we've already seen this as a symmetric difference. Good. Now let's take the right hand side. Okay, RHS right hand side of the equation. Another. Oh no, let me. Okay, just ignore this. I'm drawing it separately here. I have this and you have this. So this is set A and this is set B. What is A union B? A union B will be the entire thing, right? First of all, let's see what is A intersection B. A intersection B is this region. A intersection B is this region. Then A union B is what? A union B is the entire region. Is the entire region. Now, when you subtract, what does this mean? A union B, set difference A intersection B. That is, you are subtracting A intersection B from A union B, right? So, what do you have left? If you take out this region alone from this entire thing, what you have is this. Where do I shade blue? Except the intersecting region, everything else, right? So you just don't have the intersecting region. That is what this means, right? So your right hand side is equal to your left hand side, and hence it's truth. Okay, fine. So that is also done. What is the next thing? Oh yeah, you're done with it. The RMA mudinjiruchu. So next you have something called properties of set operations. Set operations is basic set operations, union and intersection, right? Of course, micham set difference, symmetric difference, and then you have disjoint sets, etc., etc. The basic set operations are union and intersection. Okay, so first property is commutative property. Okay, what is commutative property? Commutative property is A union B is equal to B union A, and A intersection B is equal to B intersection A. And all these properties involves union and intersection. Okay, what there is one variant that involves union, there is one variant that involves intersection. Okay, fine. So A union B will be equal to B union A. Of course, this is very simple to even prove it because you know it easily. If you take all elements from set A and all elements from set B, put them together, make it into a union set, the elements that you would get would be equal to the elements that you would get when you take B first, and then the elements in B first, and then the elements in A, put them into a union set, and then package it. You get the same thing, right? It's pretty simple. And then what happens when you take the intersection? Again the same thing. Elements of set A and elements of set B and you take what you identify which elements are common in these two sets. You have some set that is the intersection set. அதுக்கப்புறமா என்ன பண்றோம் இந்த கேஸ்ல B first எடுக்கிறோம் அப்புறம் A எடுக்கிறோம். It does not make a big difference, right? As far as the elements are going to be the same, it does not make a difference at all. So obviously this commutative property holds good. What is the second property? Second property is associative property. What is associative property? It is A union B union C is equal to A union B union C. Okay, and there is one version with intersection as well. A intersection B intersection C is equal to A intersection B intersection C. This is also pretty much same, because if you take this entire thing, okay, this entire thing, this entire set as say some x, okay, and this entire set as something else, okay, you have to take it as something else, some y, and okay, let's not do it this way, okay, just forget this x and y. I'll try to prove it using Venn diagram. So using Venn diagram, if you take, let's take this, okay, so the left hand side is what? You have three sets here, so A, B and C. A, B, C, you're taking the LHS, okay, LHS. So what is B union C? B union C is going to be all this. Right. B union C is all this. Fine. And then A union B union C is obviously everything. Okay. It's going to be everything. Now take the right hand side. What do you have on the right hand side? Right hand side. Okay, this is the right hand side. You have A, B, you have C. What do you see here? A union B another. A union B is this. A union B, union C. What is C? This. Remaining part. Obviously, this is equal to this. Okay, hence you prove it. Now let's try to prove this also. Now that we've started, let's try to prove this intersection also. So in this, let me take the left hand side. What do you have? You have okay, so you have A, B, C, A, B and C. So B intersection C. What is B intersection C? B intersection C is idu mattum, correct? B intersection C is only that. Then what is A intersection of that? This part alone. The part where A intersects with B intersection C is this part alone, right? Next, what is the right hand side of this equation? The right hand side is just that the order changes, but you're going to get the same result, and that's why it is an associative property. Okay, so you have A here, you have B here, you have C here. First you consider A intersection B. What is A intersection B? A intersection B is this. Okay, this is A intersection B. Then what do you have? Then you take A intersection B intersection C, which is this. The part where C intersects with A intersection B. Right. Now what do you see? This is equal to this. There is only one single area where both these are red colored, or rose, or whatever that color is. Okay, red color, let's say. Fine. So now we have proved the associative property, the union version and the intersection version. There is one more property. What is that? I need a new screen for that. Okay, new screen. That is the distributive property. Distributive property. What is that? A union B intersection C is equal to A union B intersection A union C. Okay, this union is taken here, and this intersection part, this becomes common here between these two sets. Okay, so this is distributive property. This is the first version. What's the second version? A intersection B union C is equal to A intersection B union A intersection C. So here union is distributed. Union is distributed across these two sets. Here intersection is distributed across these two sets. Okay, fine. So let's try to prove this taking LHS. LHS, what do you have? Let's take 3 circles. A, B, C. B intersection C is what? B intersection C is this. Okay, so B intersection C is that, and A union of B intersection C is what? You should include A also, right? So A union of B intersection C, this region, the entire blue colored region. Okay, fine. Now let's take the right hand side. Right hand side, 1 circle, 2 circle, 3 circles. Okay, A, B, C. Okay, now what is A union B? A union B is all of this. A union B is all of this. Okay. What is A union C? A union C is all of this. A union C is all of this. Okay. Union C is all of this. Okay. Now, but what is the intersecting part? Because you are supposed to find out the intersection of these two, right? Intersecting part another. இது இல்ல, அதாவது இந்த B இல்ல, because here you have only green, and இங்க C இந்த இடத்துல this region. Okay, here you have only purple. So இந்த ரெண்டு இடம் மட்டும் இல்ல. Let me indicate it using a different color. Red. Okay. So you have all this. You have all this. You have all this. You have all this. Except the regions where you have only green and only purple, right? And this is equal to this, right? That's what you see. The left hand side of the equation is equal to the right hand side of the equation. Hence, the first distributive property is proved. Now, let's take the second one. Okay. Second one. Line here. LHS first. Okay. You take the LHS again. A, B, C, A, B, and C. Okay. So, the left hand side is what? This. Right? That is B union C first. B union C another. B union C is all of this. B union C is all of this. Okay. Then A intersection B union C. That is the place where set A intersects with this B union C is only this. Right? It's only this where you have this pink and blue. Fine. So this is the only place. This is the LHS. What is the right hand side of the equation? Right hand side again. A, B and C. Okay. Right hand side another. A intersection B first to arrive. That's what you should draw first, because you have it here. A intersection B. A intersection B is this region. Okay. Fine. Then A intersection C is what? A intersection C. A intersection C is this region. Okay. And then you're supposed to find out the union here. So union is what? Obviously this entire region. This entire region. All this union. Okay. So what do you see? Here it was only this region. Here again this region. So both these are equal. So the left hand side of this equation is equal to the right hand side of the equation. Fine. So hence you have proved the second variant of the distributive property as well. Okay. So I think that's it for this session. From the next session we'll start working out examples and problems. Okay. Fine.